Good morning, ladies and gentlemen. I can't believe it took us that long, but today I feel honored to welcome you to IC America's very first webinar titled Print Inspection Strategies for Print Shops. There will be more to come. So if you like it and see another one you find appealing, please come back. If you don't like it, please come back anyway, because this session will be recorded and whatever I screw up today will be showcased to all my co-workers so they can do better the next time around. One more important clarification before we get going. Our webinars are not sales pitches, not at all. Yes, if you see an inspection system depicted on the screen, it will be ours. Yet every inspection strategy we are proposing here works with any other inspection system just as well. I'm Jürgen Klicker. I run IC's US operations out of our Chicago office since 2003, and I will be your host for today's session. Here's what we're going to do. First, there's quality objectives. When we set up a quality strategy, what exactly are we trying to accomplish? We will for sure look at different defect types and different types of systems at our disposal, as well as their limitations. We will go through several sample strategies we've set up and put them to the test for you. To do so, we'll be using two sample jobs we've created for just that purpose, and they include well-balanced sets of doctored defects. Last but not least, a quick summary and an overview over common mistakes that come to mind, and of course, some ideas how to avoid them. Now, quality objectives. First, there's QA. It means quality assurance. Protecting your customer. We're using inspection systems to catch problems and make sure defective items will not get shipped. Then there's quality control, QC. It means protecting your process and using inspection system mainly to collect data needed to keep your process in check and prevent bad items from getting printed in the first place. Commercial aspects are referring to protecting your EBIT by performing quality assurance and quality control in the most cost-effective way possible, minimizing waste and maximizing return on invest on inspection systems. Most customers I know want, of course, all of the above, but yet you find a little question mark here. Because optimizing one of these objectives will typically come at the expense of at least one of the others. So we can't fix this for every scenario. Yet today, I'm hoping to provide you the tools to find the right balance for your specific situation. First, let's look at a flawless sample print, in this case, a pharmaceutical insert. Individual events will come and go at random, like this press contamination. Repeating events appear at random but won't go away until the root cause has been addressed, like this too much pressure on the flexo plate, I guess. Systematic defects are repeating in nature as well, yet they are there from the get-go. And prepress defects are systematic defects caused in prepress. Needless to say, the strategies we will present here are supposed to catch and prevent all of the above, except for the flawless print depicted in line 1, of course. Technologies. Let's have a look at the different types of inspection systems at our disposal and their limitations. First, there are sample testing systems. We put a sample of the press, for example, and place it on a scanner for inspection. Scanners are available for different press sizes and different types of printed articles. They come at very high resolution. They can catch pretty much everything the young and healthy naked human eye can see. Yet by nature, sample testing systems are for systematic and repeating defects only. Then there's 100% inspection. Mounted on a press or on post-press equipment like rebinders and folder gluers. Naturally, these are looking at all items rather than just selected samples. So these are good to catch both individual and repeating defects. Yet depending on the machine they are mounted on, available resolution is typically just not quite enough to find everything a picky customer might be concerned about. As you may have noticed, both technologies require compromises. One finds everything on the sample testing, just on the samples it is looking at, and one finds some of what we need on all items on the 100% inspection. Our sample job number 1 we've created includes a total of 480,000 flexo labels, printed on a 17-inch flexo press, 24 up, 20,000 repeats, 6 rolls. Our customer requirement here is a 32nd of an inch for individual defects and a quarter of that for repeating defects of any kind. Now, before we get started, let's have another look at the defects on our dedicated sample jobs and adjust them to the real world. There are a lot of real world things that make two prints look different from each other, even though there's nothing wrong with either one of them. There's dot gain, distortion, register, paper defects. There's also dust and other press contaminations, all of which have an effect on print quality as well as the inspection process itself. That's why our test jobs have been amended by randomly occurring events on both the good and the bad items. These are important to highlight any type of undesired side effects to system adjustments. Back to our sample job number 1. As a reminder, here's the customer requirement again. First, we'll run the test sample 1A with 0.2% of the labels coming with individual events exceeding the individual defect threshold of 800 micrometers. 2% of these labels come with defects larger than half that size. 1A has no systematic or repeating defects. So we are expecting to catch the 0.2% labels that have individual events exceeding the threshold for these individual events. We are expected to let go of the 2% with smaller defects. So we expect the yield of 99.8% for this job. Our sample 1B is the same as 1A, just we are throwing in a repeating defect after 50% of the job. At 1C, we replace the repeating defect with a systematic defect, present from the get-go. And in 1D, we kick it up to prepress. Sample job 2 is for the sheet fed world. We're looking at 450,000 folding cartons plus 30,000 overprint to be printed on a 40-inch sheet fed offset press, 10 up, 48,000 sheets. Customer requirement is very similar to the one for the label job, except we are a little bit more forgiving for the repeating defects here. We're not quite as picky. Now, time to come up with some proposals. Some proposals are illustrated for roll-fed operations. Some are for the sheet-fed world, some work for both, and at the end, we're even going to combine multiple setups into a more complex strategy. Some of these proposals turn out to be just not working. We'll ignore those, of course. For the others, we are going to use a couple of icons to classify their performance. This one is for those where achieving our core goals comes with. Sorry for that. This one is for those where we are leaving significant portions of our quality assurance to the customer. And this one is the one where achieving our goals comes with excessive waste. Some of these strategies turn out not to be the most cost-effective way to achieve our goals. Some will just be working, and others will leave significant issues behind for other inspection systems to resolve. So here's proposal number one, a plain 100% inspection unit on a press. It acquires a golden image from the press and compares every subsequent repeat to that golden image. Thus, by nature, this is inspecting for consistency only. Technically, this is not a quality inspection, it's consistency inspection, meaning it will catch individual occurrences as well as repeating defects because both are different from our golden image. But when it comes to systematic defects, you will find the problem in both the prints to be inspected as well as the reference. Meaning in this scenario, you can even print a Chinese label that should have been Korean, and this machine won't find a thing. But for systematic defects, it's your customer doing the QA. So let's beef it up, forming proposal P2. Now, during Make Ready, we're comparing our golden image to the pre-press one-up PDF. Now we're catching systematic defects too. Yet this proposal still excludes pre-press, nothing happening over here. So when it comes to pre-press issues, we're still back to the customer doing the QA. A keep things as simple as possible idea to address this problem might be to simply use the customer-supplied artwork file instead of the pre-press one-up as a reference. Now our strategy obviously spans pre-press as well. Yet our system will also flag all legitimate pieces of pre-press work on the press, thus delaying Make Ready and diluting inspection results. In other words, this doesn't work. Adding a separate file-to-file inspection, however, is very cost-effective. Now you find pre-press problems where you want to find them in pre-press. And you clean up the print inspection from these bogus findings. Only remaining downside, when it comes to removing the bad items that you have identified on the press, you are relying on the rewinder operator downstream to remove them. That doesn't mean QA is not happening, but it means it is done by humans, not the inspection system, hence the question mark for QA. However, using this setup, repeating defects will get caught right away on the press, pretty much. And can get corrected right away, making this a very good QC strategy. To improve its QA performance, we can add a quality link, or AVT refers to it as role mapping, forming proposal P4. The quality link will feed the inspection system, the inspection results from the inspection system on the press to the rewinder. So the rewinder can be stopped automatically where defects were found on the press. Now we're having a true QA system offering some support to secure the removal of bad items, combined with a true QC system providing immediate feedback for repeating defects showing up. When we expose this scenario to this setup to all our scenarios 1A through 1D, we see near perfect results overall. Just one downside, this setup still excludes post-press issues, meaning whatever happens post-image acquisition on the press will not get caught. We're not looking. But in case of repeating defects on the press, a lot of bad labels will have been printed until the problem gets caught on the rewinder, resulting in these lower yields over here. Showing us that this is one of the instances where we improve one aspect at the expense of another. Both press-bound inspection with quality link and endpoint inspection post-press have their pros and cons. Expensive consumables pull towards press-bound QC optimized inspections. A high likelihood of significant post-press issues pulls toward QA optimized inspecting post-press. Now, sheet fed. Sheet fed ops pretty much come with the same equations as roll fed. There are some significant differences though. Some sheet fed presses offer options to automatically remove defective press sheets. That's great, better than roll fed. However, we can only remove entire sheets, not individual die positions. Meaning, if we're looking at our 10-up folding carton example number 2, we're supposed to toss out 0.2% of cartons, yet we're tossing out 2% of press sheets instead. But first, I want to use this sheet fed example to highlight something else. If your customer has separate specs for repeating defects and individual occurrences, setting up the inspection system for the smallest specs for all types of defects just in case results in this. Look at our example number 2. 2% of cartons containing at least one event exceeding 400 micrometers, you'd be losing 20% yield trying to catch a repeating defect that isn't even present in that sample 2A. So this idea results in unnecessary waste, and not just for the sheet fed example. It does that regardless of the printing process or the inspection strategy in use. But good thing, there's an easy fix for this. Find that operating manual for your inspection system and set it up to treat repeating defects separately. And ta-da! Just good results. Meaning if your customer has separate specs for different types of defects, like repeating and individual, set up your inspection system accordingly. The same logic applies for high and low priority regions. For the same reason, if there's a high priority region, assign an appropriate parameter set to just that region. That can be done at the press during make ready or optimizing consistency over multiple press operators upstream in pre-press. That will help speed up make ready as well. So in short, you want to adhere to the details of your customer specifications. So now we're catching repeating defects early, making this an excellent QC tool with a difficult retrofit in a sheet fed offset press. If you have one of these, most likely you bought it with the press. Limited resolution, not quite enough to find everything we want to find for QA purposes. A limited reject buffer, typically 20 sheets only. And there is no such thing as a quality link for a sheet fed. Making this a limited QA tool. That still excludes post-press. Overall, an excellent QC tool with limitations for QA. Now, to address the QA limitations, we would like to have the same thing done that we did for the roll fed side of things. Relocate the inspection from the press downstream to post-press equipment. Here, we're looking at individual items rather than the entire press sheet. Those are typically smaller, so you get a better resolution. So this one catches individual events and ejects and prevents overall all relevant issues. Individual, repeating, systematic, or in pre-press. It covers post-press defects too, like job mix-ups on the folder gluer. So this makes an excellent QA tool, providing a great end customer impact. And other than the press-bound equipment on sheet-fed presses, it is very easy to integrate and retrofit. Only downside, feedback is delayed. So the response to repeating and systematic print defects is also delayed. So let's run the numbers for our sample jobs 2A through 2D. job 2A with the clean make ready here on the right, only containing 0.2% of individual defects, leads us to the expected 99.8% yield here, because we're tossing out 0.2% of bad cartons rather than 2% bad press sheets on a press. Systematic and repeating issues are a different story here. Our worst case is depending on the time it takes to move a job from the press room through die cut to the folder gluer. A systematic defect on the entire job may not even get caught until the whole job is printed, leading us here. Excellent QA tool, limitations for QC. Now let's think about combinations. The low-hanging fruit would be, of course, to just combine these two. The one has the better QC performance, the other one has the better QA performance. So combining them hopefully will give us the best of both worlds, right? Right? Well, that actually works. If you put these together, if you would put these together, indeed you get an extremely good QA and QC tool. However, I am sure your CFO has a special place somewhere behind the dumpsters where people who make such proposals would get hung, drawn, and quartered or flogged. With other words, even though this might work, there are way more cost-effective ways to achieve pretty much the same results. So we give this one a money waste. So let's look at another potential partner for the possible pairing and testing. Sample testing provides the highest resolution we can get for all inspection systems for sheet-fed. It's the easiest integration, because there is none, and it's the lowest investment of all, making this an excellent QA and QC tool for repeating defects, which turned out to be exactly the weak point of the post-press inspection we had just before. With this setup, you can have press operators perform regular inspections like one of your 5,000 sheets without leaving their press for any extended period of time. The press operator brings a press sheet to the scan station and places it on the scanner, then uses the system's barcode pistol to read a barcode on the job sheet, then presses the start button and immediately returns to the press to complete the inspection press site when time permits. In a typical sheet-fed job, multiple press operators can share the same scanner and the same inspection software, making this quite cost-effective. But even better, one machine like this can easily handle 4 presses at full speed, making it super cost-effective. If we take our sample job number 2 and expose our setup to it, we'd see the expected results. Very cost-effective, high-resolution QC tool, limitations for QA. Most prominent, the X over here, it's unable to find the individual occurrences defects. Let's have a look at this side by side with our folder gluer setup. This one was a great QA tool. All 4 check marks in the QA line here, with limitations for QC. So we're thinking about putting them together using file to file for pre-press issues over here, just a piece of software integrated into your ESCO hybrid workflow. Sample testing for to catch repeat issues, and folder gluer bound inspection to find the individual occurrences. Compared to, let's say, 3 folder gluers equipped with something like this is about a 15% larger investment, providing much, much better results overall. And here's the outcome. Now, if you combine the two, as just defined, we're going to see near perfect results for almost everything. One slightly lower number is over here. And that is the repeating defect. Remember, we inspected one every 5,000 sheets, meaning if we find a defect, we have to toss the last 5,000 sheets because we don't know when it started. So it costs us 5,000 sheets to save all that money, but 5,000 sheets for every repeating defect will cost way less than 5 more inspection systems on the press. So it's still a good deal. But we see the 89% yield only for repeating defects, just because of that particular issue we can't avoid. Cost us a couple of press sheets. Summary. Quality control works best close to the cause of the defects. Quality assurance works best close to where the individual items can be removed. And it helps a lot to use separate standards for repeating defects. Consider combining systems for better performance overall, like we did in the last sample. Common mistakes and how to avoid them. A common mistake is to use a quality control system for QA and vice versa. If you see a system in this presentation that has a bunch of question marks on QA, don't use it for QA. Same the other way around. The way to avoid this is a simple piece of wisdom. Do not ask a system to do something it just can't. Not necessarily a mistake is to inspect upstream, but to inspect upstream for QA purposes pretty much requires you to have a plan for defects caused further downstream. Like, for example, that job mix-up on the folder gluer. Same the other way around. If you want to do QC and you inspect downstream, consider the unwanted side effect, which means the delayed response and the lower yields in case of repeating defects. Buying one inspection system and hoping for it to do multiple things at the same time can also be a problem. Avoid this by consider your main objective first, and once you have that one home, then start optimizing the secondary and other objectives. A huge mistake is this one. Do never ever use customer-supplied artwork as a reference for print inspection. Customer-supplied artwork does not look like you want your print to look like. Hence, it's unsuitable as a reference. Use a reference that truly represents the intended outcome on the press. And if you have to, which typically is your pre-press one-up, and if you have to convince your customer that this is good enough, please make sure your customer understands that you do use a file-to-file inspection system in the first place to approve your pre-press one-up and make sure it matches your customer-supplied artwork with regards to everything you want to see on the press. More common mistakes. Exceeding system limitations. If you have a system that is capable of finding a defect of 300 micrometers and you try to find one that's 200, you're going to drive your operators crazy. They're going to end up switching it off. The solution is the same as before. Do not ask a system to do something it can't. Exceeding print process limitations. If you can't print a certain print quality, don't try to inspect it into your product. If most items have, let's say, paper-borne defects that are bigger than your specification, setting up an inspection system, finding all of them will not make you happy. Going too close to these limitations is also a mistake, because it means that the system will have very little wiggle room and redundancy to decipher what type of defect it's looking at and making a good decision as to what is to be rejected and what's not. So that too will have an unwanted side effect on your yield. Other big mistake, use the strictest specs everywhere. That was the example with the repeating defects and individual occurrences to be treated separately. It will have a significant impact on your yield. You will have lots of unnecessary waste because of it. Extreme example is customers who have, let's say, labels and set the inspection system up to even find defects between the labels. Now we are stopping the rewinder for a defect that won't even be present on the label that you ship. So you wanna make sure your specs reflect what your customer really wants to receive. Same holds true for priority regions like the lot and expiration date. For example, if you have these things, consider masking. Can be done on the press, where it has a little bit of a negative effect on the make ready time. But you can also kick it upstream and have it done in pre-press. So the press operator already finds all the settings where they belong when they start the thing. Perfect. Thank you very much. We are going to send you the presentation as well as the access to the video if you want. So you can always have another look later. We also appreciate if you can give us some feedback. As I said, this was our very first webinar. We want to learn from it and do better next time. So the more we know about what you liked and what you didn't, the better. Thank you very much.